Welcome back, Calculus. Here in this video, I'm going to do some examples on how to differentiate functions that contain sine and cosine. And then through those examples, I think you're going to learn a little bit more about it. I drew these cute little hearts all around our basic facts because to do derivatives that involve sine and cosine, we have to remember that the derivative with respect to x of the sine of x is cosine of x. And the derivative with respect to x of cosine of x is negative sine of x. These are facts that are worth keeping in your heart. They will help you in the rest of your calculus journey, and they're one of the few things that I recommend students memorize and just keep as facts that are ready at your fingertips. So I'm going to use these facts to give us and to help us do a couple of examples. So, first example, find the derivative of the function f of x equals 5x cubed times sine of x. This is an interesting one because we're going to need to be able to take the derivative of sine of x, and we're also going to have to use the product rule here. Because notice this breaks down into two functions. We have the sine of x, and we have 5x cubed. So we have two functions here multiplied by each other, and we want to find that derivative. So f prime of x is going to equal the derivative of the function in blue, which is 5 times 3 times x to the 3 minus 1. Here I'm using the power rule. So we'll use the derivative of the function in blue times the function in red. Then we're going to add that to the function in blue times the derivative of the function in red, which I hope you have written in your heart. The derivative of the sine of x is cosine of x. And we'll just simplify this a little bit and clean it up. So the product of 5 and 3 gives me 15. X. 3 minus 1 is squared. Then we have sine of x plus 5x cubed cosine of x. And that's my final answer. So that's an example where we take the derivative of a trig function, and we had to also use the product rule. Let's go on to example 2. So for example 2, let's say find the derivative of y is equal to sine of x cosine of x. So here we're going to have to use the product rule again because I have the product of two functions. Sine of x will do as our blue. Cosine of x will do as our red. And I'm using a little bit of different notation here. I said y instead of saying f of x. And let me show you how that would look notationally. I'll say now the derivative of y with respect to x. You could also say dy by dx. But what this is really saying is I'm taking the derivative of the function y. The function y is equal to sine x of cosine of x. And how am I taking that derivative? What variable am I focusing on? I'm focusing on the variable of x. Oh, sorry, I wanted that to be a highlighter. I'm focusing on the variable x. So that's why the derivative is with respect to x. And what am I taking the derivative of? I'm taking derivative of the function y. So that's where that's coming from. Okay. So as before, we're going to have to use the product rule. I have the product of two functions. Sine x is our first function in blue. Cosine of x is our second function in red. And so I'm going to take the derivative of my function in blue. So the derivative of sine x is cosine x. And I'm going to multiply that by the function in red. And I'm going to add that to my function in blue, sine x, times the derivative of my function in red, the cosine of x. Now remember, when I take the derivative of cosine of x, it actually gives me negative sine x. And so we just have some algebraic simplifying to do here. Cosine of x times cosine of x gives me cosine squared x. Sine of x times sine of x gives me sine squared of x. And because I have a negative times a positive, this is going to give me minus sine squared of x. I'm trying to think if there's anything fancy I can do with my Pythagorean identity here. So recall, we have this information from our trig classes. The cosine squared of x plus sine squared of x is equal to 1. So then let's go ahead and solve for cosine squared x and see if simplification, if we can do anything cool. So cosine squared of x then would be equal to 1 minus sine squared of x. So I'm going to go ahead and use that substitution in here, because I'm saying the cosine squared of x is the same as 1 minus sine squared of x. So I'm going to put that in here and see if that gets us anything interesting. 1 minus sine squared of x minus sine squared of x. 1 minus 2 sine squared of x. Yeah, I could keep playing with trig identities if I wanted to. But I don't see that it would take us anywhere special. So we're going to leave this as is. I would also accept this answer that we got above. The thing that's tricky about taking derivatives with trig functions is a lot of your trig identities come back into play. Like this for Pythagorean theorem fact will come back into play. In the proof for the derivative of these functions, we used the double angle formula or the sum of angle formula. So a lot of that trig that you maybe left behind and wished never to see again is going to come back. But it's okay, because we have the internet and we can look up any trig identities we forgot. So here's your pro tip. Don't be afraid to look up trigonometric identities. I'm going to say identities and facts. A lot of students are weak in trig, and that makes this section of calculus challenging. It's okay. You can look stuff up. You don't have to remember it. If you get stuck on a problem because the trig is freaking you out, look it up. No shame in the game. So let's do another example here. Let's suppose I have a function, h of x is equal to cosine of x divided by 4x squared. And we want to find the derivative. Find h prime of x. So now here we have a quotient. So instead of using the product rule, we're going to use the quotient rule. And I told you guys not to be afraid of looking stuff up. If you hear me typing in the background, it's me double checking the quotient rule. I have a mental block when it comes to the quotient rule. I personally do things a different way. I'll show you when we get to the chain rule. I'll show you how I handle it. But I still have to know the quotient rule. And so I just look it up. When I get stuck, I look it up. And then I'm able to show you how to do it, and life's good. Okay, so I found it here. So for a function, here's our quotient rule. If I have a function h of x, and that is an f of x over g of x, right? I have a function divided by another function. Then h prime of x equals g of x times f prime of x minus f of x times g prime of x, all divided by, if I take that whole function, everything in the denominator, and square it. So I'm going to use this here because I see the function in the denominator, that's 4 of x squared. So everywhere I see g of x, I'm going to put that function. And the function in the numerator is f of x. So that's my function cosine of x. And I will fill that in everywhere I see f of x. And I also see that I need f prime of x and g prime of x. So I'm going to need to find the derivative of my numerator and the derivative of my denominator. So my function f of x is the numerator, cosine of x. So f prime of x would then be negative sine x. And my g of x in the denominator is 4x squared. So the derivative of that function, oops, I said d of x, that's silly. Don't know where that came from. Quarantine's getting to her. G prime of x will be 8x. And then because I'm also going to need to know it, I'm going to look at, if I take g of x, the whole thing, and I square it, that's going to be the whole thing 4x squared squared. And that's going to give me 16x to the 4th. Don't be shy if that was a little tough for you. Just review your laws of exponents. That's what I'm using here. Use your laws of exponents. You could say exponent rules, I think. That's what I'm using. Now that I found all that stuff, I can go ahead and plug it into my quotient rule. So for our function, h prime of x, that's going to equal g of x, which is 4x squared, getting that from here, times f prime of x right here, which is negative sine x. Then I subtract that from that, my function f of x, which is cosine of x, times g prime of x, which is 8x. And then I divide all of that by g of x squared, which is 16x to the 4th. That's going to be my derivative. I'm going to do some cleaning up here. So then that gives me h prime of x equals negative 4x squared sine x minus 8x cosine x all over 16x to the 4th. I'm going to look in my numerator for the greatest common factor. And that's going to be h prime of x equals negative 4x. And multiply in x sine x plus 2 cosine x, all divided by 16x to the 4th. I found that greatest common factor so that I can do some cancellation at this step. So now I can hopefully notice that negative 4 and 16 have common factors, and x to the 4th have common factors. And I get h prime of x is equal to negative x sine x plus 2 cosine x all over 4x to the third power. I'm going to go ahead and distribute that negative sign to get negative x sine x minus 2 cosine x all over 4x cubed. And that would be my final answer for that derivative. The hard part here is algebra and trig. Stick with it. I'm going to do one last example. Again, using the quotient rule. Maybe I can conquer my fear. So let's say we have a function h of x equals x divided by cosine x. And so we want to find h prime of x. We have the quotient rule because I have this function in blue divided by this function in red. And so the quotient rule says h prime of x is going to be equal to the function in red, cosine of x, times the derivative of the function in blue, which is just 1, subtract the function in blue, x, times the derivative of the function in red, which is negative sine x, and all divided by the function in red, quantity squared. So what that looks like is I take the whole thing that's down there, cosine of x, and I square it. So let me simplify this a little bit. That gives us h prime of x equals cosine of x plus x sine x, all divided by cosine squared of x. This can be further simplified. And it's going to take some heavy-duty trig to do so. So hang with me here. First thing I'm going to do is separate my functions. H prime of x equals the cosine of x over the cosine squared of x plus x sine x over the cosine squared of x. This allows me to cancel a common factor and say this is 1 over cosine of x. Here I'm going to factor some stuff out. I'm going to say this is x times sine x over cosine x times 1 over cosine x. I'm going to pause here for a second so that you can see where I got all that from. The x I pulled out like this, and then I had sine x over cosine squared x. So I separated that cosine squared into cosine times cosine, so that I could have sine x over cosine x and 1 over cosine x. So here's the trig. Oops. One over cosine x is the same thing as secant x. Wait, I had a moment of doubt. Let me check it. Secant x. Yep, that's 1 over cosine x. My moment of doubt. So then we have 1 over cosine x is equal to secant of x plus x. And then I hope you remember that sine x over cosine x is tangent x. And then 1 over cosine x is secant x. And then I can factor this out to say h prime of x equals secant x times 1 plus x tan x. Isn't that nice? The point of doing this simplification is, let's say for the sake of argument that you're actually trying to use this to calculate something. This is a lot more straightforward to use in a calculator or in a computer program than this. So, like I said, don't be afraid, look stuff up, okay? So it might be a good idea to find some trig identity fact sheets for your notes so that you can start to practice using those trig identities to simplify and change